Now, in public opinion polls, when they want to try and find out the attitudes of the opinions of the American people, you're talking about over 100 million adults, they go ahead and they randomly select around 1,500 people, 1,500 people, to go ahead and try and estimate the opinions of 100 million people. Now, most people, when they think about that, go, well, that's dumb. That's not nearly enough people. And hell, I've never been called. So most people think public opinion polls don't work because they can't work. How can you call so few people and still go ahead and think it's going to work? There's just no way that that's going to happen. Okay. The reality is that we do this sampling all the time. We just don't think of it as sampling, but we do it all the time. So that's why we're talking about spaghetti sauce. So I don't know if you've ever made spaghetti sauce, and by the way, I'm not talking about like pouring ragu into a pan. I'm talking about actually making spaghetti sauce. And for those of you who don't like meat, I'm sorry, I'm going to have to give you a meat spaghetti sauce story. But if you go ahead and you make spaghetti sauce with some kind of meat, what happens is you usually put your meat in, you grill, you brown it, right? Then you pour your tomatoes in, your tomato sauce in, you pour your tomatoes in, you put in some spices, and you let it simmer. Now I'm talking about a big bowl of spaghetti, a big pan of spaghetti sauce. You're going to be making spaghetti for 100 people. You got a big bowl of spaghetti sauce cooking. Once you get everything in there, you got all the juices, you've got the spaghetti, the bowl is sitting on the pan is sitting on the stove, it's simmering away. You let it sit there for, I don't know, 6 hours, 7 hours, so all the juices can mix in together. If you were to go ahead and say, okay, look, it's been cooking for 6 hours, I need to go ahead and taste it, I want to see if it's good. Well, if you've never cooked spaghetti sauce, what happens is, if you're cooking with meat, is at the very top of the pan, there's going to be this very thin, clear layer. It's like totally, you can see it there, but it's totally clear. Now, I know in the past I've asked students, what is that? And I had one student who said, yeah, there's the water at the top. That's not water. That would be called fat. That's fat, right? That's the fat at the very top. Well, if you wanted to find out how your spaghetti sauce tasted, here's what you wouldn't do. You wouldn't take, you got this big old giant pot cooking on the stove, you don't take a little bit off the top and taste it because you will puke into the spaghetti sauce. It's disgusting. It's just fat at the very top. So what do you have to do? If you're going to taste your spaghetti sauce, you have to stir it up. Well, let me go a little all political science geeky on you here. When you're stirring up your spaghetti sauce, what you're really doing is you're taking the contents of that big pan of spaghetti sauce and you're putting it in random order. You're randomizing your spaghetti sauce. From a geeky political science perspective, that's what you're doing. You're randomizing the spaghetti sauce. Before you start stirring it, little sample off the top. I mean, there's a little film at the top, then there's some like your sauce and sort of watery stuff, then there's the tomatoes, and at the very bottom there's the meat that you put in. You got to get that in random order. And once you've mixed it up and it's all in random order, you've mixed it up nice and good, then you take a little tiny spoon and you go ahead and you taste it. And you go, that's good. That's good spaghetti sauce. Well, think about what you've just done. You've randomized the spaghetti sauce, you put it in random order, you've taken a small sample and tasted it, and you've made an inference. You've made an assumption about the big pot of spaghetti sauce based on that little tiny spoonful. That's what you're doing. You're doing sampling. When you're cooking, that's what you're doing. You don't have to eat a whole bowl of spaghetti sauce to find out how the pan tastes. If you mix it up really good, and then you take a little sample off the top, you can make an inference. You can say, well, since this spoon, what I had on the spoon was really good, I'm going to infer that the spaghetti sauce was good too. And the reality is suppose you had like a swimming pool full of spaghetti sauce. You have the biggest pan ever. You go into the Guinness Book of World Records. You're shooting for the Guinness Book of World Records with the biggest pot of spaghetti sauce ever. You have rocket engines like blowing on the bottom of it so that you can go ahead and cook it. If you want to find out if it tastes good, you do the exact same thing. you would randomize it. You would stir it up so it was all really, really mixed up. And once it's all really mixed up, you could take 1, maybe 2, maybe 3 samples off the top, and you could make an inference about that big, huge pot of spaghetti sauce. All you're doing is the same thing they do with public opinion polls. You're taking a sample, a small sample, and you're making an inference. You're making an assumption about the population. You're basically saying, if the spaghetti sauce in my spoon is really good, then the odds are the spaghetti sauce in that big giant pot is really good too. Here's another example. Have you ever noticed that when they take your blood, like you go to the doctor wants to take your blood, they don't take it all. They don't go like, we need to look at your blood, and then suck it all out, and then you get all, shrivel up and stuff like that. It doesn't work that way. What do? They stick the needle in, and they take a little bit of vial out. And what they're doing is they're taking a sample of your blood, and they're going to make an inference from that small sample about all of your blood. If they find out that you've got some sort of problem with a lack of iron, they're not going to say, oh, you have a lack of iron in this bit of blood. They're going to say, you have a lack of iron in your whole body. All they're doing is taking a sample. That's what public opinion polls do. Public opinion polls do the same exact thing. They're doing a sample. Now, there are good samples and there are bad samples, right? The way we want it to be is that if we're sampling our spaghetti sauce, if we mix it all up nice and good, and if what I have in the spoon is similar to what I have in the pan, in the pot, then that sample, we call that sample representative. That it is representative. What's in the spoon is representative of what's in the pot. But like suppose I mix it up and by accident I go ahead and I scoop it up and I've got like some peppercorn that didn't cook very well. So I go ahead and take a sample of my spaghetti and all of a sudden I'm chewing on a peppercorn. I'm like, damn, that's awful, right? Then I have a bad sample, meaning the sample is not representative, meaning that what's in my spoon isn't representative of what's in the pan. Well, when you're doing public opinion polls basically work the sample the same way. If the people in your sample are similar to the people in the population you're interested in, we say that the sample is representative. Your sample looks like the population. If the people in your sample are not similar to the population, then we say your sample is not representative. Okay? And polls are accurate, or I should say most accurate, when the sample is representative. If the sample is representative, then the estimate will probably be good. But if the sample is not representative, then the sample is probably going to be bad. Right? I mean, the estimate is probably going to be bad. If the sample is not representative, the estimate is probably going to be bad. Now, be sure to write that down in your lecture notes so you don't forget that. But if the sample is representative, the people that you've randomly selected are similar to the population, then the estimate that you make is probably going to be good. If it's not representative, the sample of people is not representative, then it's probably going to be bad. Now, the estimate is probably going to be bad. Now, it's impossible to know for sure whether or not our samples are good, whether we have a good, and then therefore it's impossible to know whether we're making a good or bad estimate. But here's what we can do. We can sort of estimate whether or not we have a good sample. We can estimate whether we have a good sample or not. And we know that basically just through statistics. Through statistics alone, we can do this. So I'm going to present this to you, and then I'll explain it on the next video clip. But just think about this. Suppose you have a bathtub, and it's full of 1,000 marbles. 700 of them are red, and 300 of them are blue. They've all been mixed up randomly, so they're in no particular order. They've all been mixed up. Okay, now, I've done that, and now I'm going to go ahead and I'm going to randomly select 10 of them. You didn't see which ones I picked. When I do that the very first time that I pick those marbles, I pick in one, I grab another one, I grab another one. When I do that very first one, can you tell, without seeing them, how many marbles, how many red marbles I have and how many blue marbles I have? Well, the answer is no, you can't. You can't possibly know. I could have got, even though there are red and blue ones, I may have pulled 10 red ones out. Could be crazy, wild thing. I could have somehow picked 10 blue ones. We don't know for sure. But if I go ahead and I do that once, and then I write down how many I picked, and then I do it twice, and then I do it 3 times, and I repeat that process 20 times, can you tell me on average how many, if I look at all of them, on average, how many red marbles am I going to pick? On average, I'm going to pick 7 marbles. Sometimes I'm going to pick 9. Sometimes I'm going to pick 5. Sometimes I'm going to pick 10. Sometimes I'm going to pick 4. Sometimes 6. Sometimes 8. Sometimes 7. But on average, I'm going to pick 7. So we can tell by statistics alone what the chances are that we're going to get a good sample, just by statistics alone. And that's very important, because although we don't know exactly whether the one sample that we took is a good one, we can estimate the odds that I got a good sample. And in every public opinion poll, there's a number that goes ahead and tells you the odds that the sample is good, and that's what we're going to be talking about next.